XML just works. XML has great IDE usability. XML has comments. XML supports any formatting. XML is just great. Or is it? Before we jump straight into the video, I'd like to introduce you guys to my buddy John Hammond, who's going to be joining me in today's episode. Take it away.
Hey, how's it going, everybody? My name is John Hammond, and I have a small YouTube channel that takes a look at capture the flag challenges and cybersecurity concepts just like this one. I want to give a special thank you to Pwn Function for letting me co-host here, and I'm really looking forward to this. Let's start with XML. XML stands for Extensible Markup Language, similar to HTML, but the main difference is that HTML is about the data representation, however XML is more about the data transportation and sometimes storage. XML is human readable, and it's used in a ton of places like APIs, UI layouts, and styles in Android applications, configuration files, RSS feeds, and a lot more. Let's look at a quick example of an XML document to understand the structure of it. The first line specifies the XML metadata, in this case the version which will be used by the XML parser at the time of processing, and this is optional for some parsers. Here, the person tag is the root element of the document, and every well-formed XML document has to have one and only one root element. Inside the root element, we have two more nested tags, name and age with some values. There's some syntactic rules for a valid XML document, and here are some of them. Tag names are case sensitive. This means the opening and closing tag names have to be exactly the same. Certain characters like quotes, ampersands, and angle brackets are not allowed inside of an XML document directly because the parser would have a hard time understanding if the input was part of a value or just a tag. The workaround for this is something called entities. Entities are simple storage units. Think of them like as variables for XML. You can assign a value to it and use it multiple times in different parts of the XML document. These entities are defined in a separate part of the XML document, called the Document Type Definition, or simply DTD. Let's take a look at a simple example to see how DTDs and entities work. As you can see, we've just modified our previous example. An entity is created inside a doc type, which basically tells the XML parser that this is a document type definition, inside which we've defined a storage unit, or simply an entity, and we've named it as name. Instead of writing John directly as the value of a tag, we've used an entity and referred to it down in the name tag. This saves a ton of time when it comes to the use of the same values in multiple places inside the XML document. There are three types of entities. They are general, parameter, and predefined entities. The example that you saw just now is the case of general entities, where we just have some value that's being referenced somewhere else. Parameter entities are somewhat special. These are only allowed inside a DTD, and they are more flexible. For example, creating an entity whose value is another entity. This feature is really useful when it comes to exploiting XXEs, or XML External Entities. Lastly, we have predefined entities, which are just a set of predefined values of some special characters, like quotes and ampersands, which might break the XML document. For example, when you try to use a less than symbol in your document as a value, the XML parser would error out. Why? Because like I had mentioned earlier, special characters like angle brackets and quotes can break the XML document. So in order to get around this problem, we have predefined entities. So instead of using a less than symbol directly, you can use this, ampersand $X3C, which is basically the hex representation of the symbol's ASCII value.
Now that we know a bit about XML, it's time for us to jump into some security parts of it. Let's start with entities. Just as we saw earlier, entities are just like variables, which can store values and then can be used later on. But XML is much more than just storing some values in an entity and using them. There are a lot more features offered by XML standards, and external entities is one of them. Entities can not only store the value that you specify, but they can also pull values from a local file or even fetch the remote data over the network and store them as entities for later use. And as you can see, this opens up a wide range of attack surface.
Now let's take a look at how external entities work. In this example, we have an entity called subscribe, and it's being used down in the pwn tag. You might have noticed that the syntax for the entity definition is a bit different than what we saw earlier. There's a new keyword called system. And what's that? Well, system is a keyword used in an entity to let the XML parser know that the entity is a type external, simply telling the XML parser to fetch the external resource and store it inside the entity. Another thing to keep in mind is that if the external resource was anything remotely close to the XML syntax like a tag, then the XML parser will throw an error, letting you know that the XML parsing failed. We'll get back to this in the later part of the video, but for now, just remember that this is an expected behavior. Now coming back to the example, the last part you need to know is that the value of this entity is not secret.txt. Well, in fact, that's just the name of the file you would like to read from. The actual value is going to be calculated at the time of parsing. The file name doesn't have to be like this. XML accepts any valid URI, which includes file, HTTP, and other protocols. And now, if we parse the XML file in an XML parser, boom, you see the contents of the file secret.txt. Let's try this with its setter password. We modify the value in the XML to the file that we want to read, and boom, we see the contents of its setter password. And there you go. We have the ability to read local files, and this attack is called XML External Entities, or simply XXE. And reading local files is just the beginning. Instead of a file name, we can also provide a URL like this, and the XML parser would happily fetch the resource for you.
There are different types of XXEs, mainly in-band, error-based, and out-of-band. The previous example was pretty much about in-band XXEs, where the XML will be parsed and the output will be shown directly onto the screen. The error-based is somewhat like a blind XXE, where you don't get to see a lot of information except a bunch of errors. Lastly, we have the OOB, or out-of-band XXEs. These are truly blind, which means the XML will be parsed and you don't get to see any of the output, and you would have to do some sort of an out-of-bound request to exfiltrate the data. Let's look at a simple out-of-band XXE scenario. We have this web application, which parses your XML input and says nothing about it in the response, meaning that this is just a blind XXE. So to test for blind XXEs, we can simply make a request to our web server using external entities instead of the file path. Let's try that. If we use the same XML code from the earlier example and modify the file path to an external URL, in our case it's just going to be attacker.com, and if we send it over, we get the request logged in our server. Nice! This confirms that the server is properly parsing our XML and trying to fetch an external entity. This is cool. We can make requests as the server. This is also known as server-side request forgery, or SSRF in short. But can we do more than just making random requests? Well, we do know that we can read local files from the server and display it. But can we exfiltrate the same file contents in a blind XXE attack? Yes, we can. But before jumping into the attack, let's talk a bit about DTDs, because they play an important role in the XXE attacks. We've seen DTDs before. They look something like this. They are defined inside a doc type. You might have noticed that the DTD isn't directly a part of XML data. They are defined above the root element in an XML document. This might be a hint to another feature of DTD, that is, DTDs can be loaded externally just like entities. You can also specify a URI, then at the time of processing, the parser will fetch the external DTD and parse its contents. This allows you to have an organized XML document by separating the definition from the data. This feature is very useful, not just for developers, but for attackers as well. If you can load an external DTD, then you can unlock another feature of XML, that is, you can use parameter entities within the markup declaration itself. Let's look at a simple example to understand the whole mess a bit more. Consider this example. We have an internal DTD, or document type definition, and we have defined a special type of entity called parameter entity. This lets us do some crazy things like defining one entity inside another. The parameter entities are only allowed to be referenced inside a DTD. Below the definition, we have our main markup, that is pwn_tag, and we've referenced a general entity inside of it. Now let's trace how the XML parsing works on a high level. When the XML parser sees this code, it first looks at the version. Based on the version, it starts processing the markup. The next thing that it does is it looks for a DTD, or document type definition, that we have defined inside the same XML document. This is also called inline DTD. Then it looks at the percent symbol and it would try to parse it as the parameter entity. Now it assigns the markup of the general entity as the value to this parameter entity. In the next line, we're trying to reference the above parameter entity that we just created so that the parser will replace the value of that entity at that position. At the end of the definition, after parsing it, it might look something like this. As you can see, it's very straightforward at this point. Now we can access the value of the general entity by referencing it inside the pwn_tag. So now that we know we can use the parameter entity directly inside the DTD, let's try to construct a blind XXE payload. Consider this as our payload. Let's quickly run through the XML parsing, ignoring the stuff that we already know. Firstly, the parser will read the contents of the XE password and store it in passwd entity. This is a parameter entity and not a general one because we want it to be used inside the DTD. In the next line, you can see that there is a general entity as the value of the parameter entity called wrapper. Now, when the replacement happens, the entire markup might look something like this. As you can see, this is a general entity, and when you try to reference it, it will make a request to an external resource, and the contents of the file will go along with it as a part of the URL. Boom, we can steal the contents of the file in a blind XXE, right? Let's try that. And nope, it didn't work. Why? Because according to XML specification, in an internal DDT subset, parameter entity references must not occur within the markup declarations. This means that you cannot reference a parameter entity within the markup declaration, but you can reference it in the same level as the markup definition. Well, that's kind of confusing, to be honest. So this video is still running, it's not yet over. So that means there is a bypass for this, right? Yes, there is. It's through external DTDs. Whatever I just explained to you doesn't work within an internal DTD, but the specification also states that this constraint doesn't apply to external DTDs. So that means we do have a bypass. All we have to do is use an external DTD instead of an internal one. Now let's try to include a simple DTD file into our XML. As you can see, there are no entities defined within the doc type itself, but we're trying to include an external DTD which has all the entities we need inside of it. So now when you try to include it from an external resource, it works exactly like we saw earlier, but it also allows you to use parameter entities more flexibly. Let me explain. Consider this payload. We have an XML file with an external DTT attached to it, and we're referencing a general entity, send. But where is this send entity? Well, the send entity is inside the evil.dtd file. Let's see the contents of it so that we can understand everything more. As you can see, we're doing the same stuff. After reading the passwd file, then we can create another parameter entity which is called wrapper and has the general entity send as its value. Then when the wrapper is referenced down below, it replaces the contents of the passwd file in here as a part of the URL and make it as a general entity. So now in our main XML file, we include the DTD, and this is pretty much replaced with what we just calculated. And now we do know where the send entity came from. It's right here. And when you try to reference it, it will make a request to fetch the external entity, but it doesn't get anything back. And we don't really care if it gets a valid response or not, because we have successfully exfiltrated the passwd file. Now let's try this. I have the server which hosts the DTD file, and I'll also have the netcat listening on port 1337, and it's waiting to receive the contents of the passwd file. Now when I send the XXE payload to the server, boom, I get the contents of the passwd file. Sweet.
Alright, now that we know how to exfiltrate the password file, let's try the same with some other file, like etc.fstab maybe. It's just a file which contains the necessary information to automate the process of mounting partitions. Let's give this a shot. It didn't work. What happened? As you saw, we didn't change anything except the file name. It worked with etc password, but not etc.fstab? Let's check out the contents of fstab. It seems fine. Or is it? As you can see, there are a bunch of comments, some of which look like XML tags, so the parser will try and parse the contents, but as you know, they're just comments and not well-formed XML syntax. So this breaks the parser and it errors out. So how do you exfiltrate such breaking data? The answer is CData. CData stands for character data, and it's a special syntax which can handle these breaking artifacts. Whatever is in between the opening and closing CData tag will not be parsed as markup by the XML parser. Awesome! It's exactly what we wanted. The syntax for the CData looks like this, and it begins and ends with this syntax. For our XXE attack, can we do something like this? The idea here is that start will be replaced by this, and end will be replaced by that. So in the end, it looks something like this. But this doesn't work because it's a violation of the specification. The value of the general entity has to be well formed, which means you cannot have an open CData tag like that. Once you open it, you have to close it within the same entity. But we're trying to split them into multiple ones, so this doesn't work for us. So the solution to this problem is to use parameter entities and external DTDs. The XML looks very similar to the one we saw earlier, but there are minor differences in the DTD. We are reading etc.fstab, and we're also defining two parameter entities, which are basically the starting and ending points of the CData tag. In the end, we create a wrapper, which has a general entity with all the three values as one. In the end, everything looks something like this. And now we can exfiltrate the data. But if this is a blind XXE, you have to include another DTD and then send the data over just like Pone showed you earlier.
XML is not just used in APIs, but they're also used in a ton of other places like SVGs, PDFs, Office documents, and others. If you want to listen to an awesome story on blind out-of-band XXE via PDF file uploads, check out Stokes' video. In this video, we've just explored how we could read files off of the server, but you can do a lot more than that with XXEs. You can also do DOS attacks, which I'm not a fan of, but still you can eat a lot of computational resources on the server and it's worth taking a look at it. You can also perform server-side request forgery attacks via XXEs, and Fulcrum on Hack the Box is a great example for this. If you want to know more about this, check out IPSEC's walkthrough video on it. And in some cases, it's possible to gain remote code executions as well. Additionally, check out the works of Nicholas, and I'm not going to try to pronounce his last name because it's hard, to be honest. And also, I'd like to thank John for joining me in this episode. Check out his channel as well. I'll leave the links to everything in the video description. I'd like to say one last thing. XML parsers are weird. Each parser behaves differently, even though there's a good specification for it. Honestly, I don't understand them. So, XML is old, XML is complex, XML is not great, and XXE is just the beginning.